I have this fantasy world that I've been building for a while. I've already added a hell of a lot of detail where it matters most, but I'd like to go more in depth, do some actual science every now and then. So, let's start at the beginning, with a rock in space that may or may not hold life. Let's start with the mass and radius of our planet. You will only really need those two values if you want to fuck around with actual orbits or do some in-depth work with stuff like atmospheric density, surface pressure, local gravity, that kind of stuff. I will be world building a binary planet. That's the thing that Pluto Charon are, but unlike my favorite technically asteroids, my two planets will both be Earth-like instead of icy rocks. So I do need these values, and I kinda need to do a hell of a lot of work with them. The easiest way to get planetary properties for a world building project, of course, is to just take reference from the wiki page of Earth, adjust both up and down by a couple of percent, and just be done with it. If you plan to do that, but want a little bit more accurate version, then, well, this paper correlates surface gravity of a planet with its mass. So I did some math shenanigans and got this relation between mass and radius for you to use. That should only be necessary if the difference in size between your reference and the invented planet is huge, which does have a lot of other implications, but it is technically more accurate in all cases. Note though that if you want to create a gas giant, they use a slightly different relationship. The exponent should come out to, I think, 1/3 rather than 1/2. For my project, I want to have a custom surface gravity on both of my planets. One with roughly 15% less gravity than Earth, and the other one with roughly 6% more. So I will go back to the root of that relation, where we started with surface gravity and mass. I'll resolve for mass, plug my surface gravity values into an Excel sheet, and boom, we have the planetary mass of two Earth-like planets. Mass done. Now that I have both the mass and the surface gravity, I can get the radius from the formula for, well, gravitational acceleration. I'll just resolve the whole thing and plug in my values. Of course, in the same units that the gravitational constant uses, and done. We can check the approach against the measured values of Earth by, well, comparing the output with the measurement. That is slightly less than 1 Mount Everest of error, but it's also about 3 digits of correct. Point is, that is probably correct enough, especially considering we aren't accounting for the obliqueness, basically how squished our planet is, so I think it's good enough for now. Neat, radius done. If you didn't start with surface gravity, you can just get it the other way around. Just plug the mass and the radius of your planet in, and do remember that this is a rounded average. It will be slightly different in different places around the planet. Now, these values don't have all that many implications on their own yet, but I am going to have to reference them for many of the orbital calculations that I'm planning to do. If you want to see that, I guess you can peer pressure me into making that stuff videos too. And of course, there's a button that'll send you a reminder. In either case, we can already get some basic estimates of some things like the planet's surface area and volume. That being a surface area approximately 85% of Earth's for the smaller planet and 106% for my bigger planet. The volumes are also roughly 79% and 110% of Earth's respectively. I could get into rotational properties, basically how long the day is, to get more accurate estimates. But these values are good enough to take a first estimate of the density of the two planets too. That gives us 92% and 103% of Earth's density respectively. All of these seem like realistic values, and my sanity check never spikes above like 0.3%, so it should be accurate enough. If you found anything weird though, please do point it out. Otherwise, I hope to continue this project soon. The host, aka YouTube, recommends the following videos to you.